Most developers now use AI coding tools. GitHub survey says 92%. Stack Overflow's data is closer to 76. The exact number doesn't matter. The point is, almost everyone is using them. But here's the stat nobody talks about. A controlled study by METR and RAND gave experienced open-source developers real tasks in real code bases and found no significant speed-up from AI tools. In some cases, developers were actually slower. Now, this was a specific setup. Seasoned developers, repos they already knew, but it tells you something important. Using an LLM is not the same as using it well. Today, I'm going to show you the 6 biggest mistakes developers make with LLMs and what to do instead. This isn't another prompt engineering tutorial. This is about the fundamental mistakes, the ones that waste your time, your money, and sometimes introduce bugs you don't even know about. A Git-clear analysis of 150 million lines of code found that code churn, code that gets written and then quickly reverted, went up 39% since AI coding tools became mainstream. We're writing more code, but not better code. Let's fix that. Subscribe if you want no-hype AI breakdowns every week. This is the most common mistake, and it's embarrassingly simple. Most developers type something like, "Write me a function that handles payments and expect production-ready code." The average prompt is about 15 words. That's not a specification. That's a wish. Here's what the research shows. Anthropic and OpenAI both document that structured prompts with few-shot examples improve output quality by 20 to 40%. That's not marginal. That's the difference between usable code and garbage. But here's the thing that surprised me. A recent study found that generic improved prompt templates, the ones you see in blog posts and cheat sheets, actually hurt performance on specific tasks. One template dropped extraction accuracy from 100% to 90 on Llama 3. Task-specific prompts beat universal templates every single time. So what does a good prompt look like? 3 things. First, be explicit. Give the LLM a role, constraints, and context. You are a back-end engineer. Write a Python function that processes Stripe webhooks, handle idempotency, return structured errors. Second, give examples, at least 5, according to the Applied LLMs team. The LLM calibrates its output to match your examples. Third, structure your prompt. Anthropic's own guide says separating instructions, context, and examples with clear headers improves quality by up to 30%. And one more thing, context management. Developers dump entire files, full conversation histories, and irrelevant docs into the prompt and wonder why the output degrades. LLMs don't just ignore noise. Noise actively pushes out signal. Anthropic's guide specifically recommends putting long documents at the top and your query at the bottom, and pruning anything the model doesn't need. Less context, better results. Counterintuitive, but true. 15 seconds of prompt structure saves you 15 minutes of debugging. Every time. This one costs real money. Most developers default to GPT-4 or Claude Opus for everything. Writing commit messages, formatting JSON, simple classification, generating boilerplate. That's like hiring a senior architect to paint a wall. Here's the reality. Industry estimates suggest 40 to 60% of enterprise LLM budgets are wasted on over-provisioned models. Most of that spend is on tasks a model 10 times cheaper could handle just as well. The right approach is 3-tier routing. Simple tasks, classification, formatting, extraction. Go to small, cheap models. General coding tasks go to a mid-tier model. You only reach for the frontier model when you genuinely need complex reasoning or multi-step problem solving. Model routing frameworks have shown you can keep over 90% of top model quality while cutting costs dramatically. And if you're not caching, you're burning money twice. Prompt caching saves you on repeated input tokens with 0 quality loss. Both OpenAI and Anthropic support it natively. Batch APIs give you a 50% discount for non-urgent requests. Teams that combine routing, caching, and batching typically cut their LLM spend by 60 to 80%. Not a marginal improvement, a fundamental one. If your LLM bill surprised you last month, this is probably why. This is the one that separates hobbyists from engineers. Most developers test their prompts by trying a few examples, eyeballing the output and shipping it. That's not engineering. That's guessing. Let me paint a picture. A team ships a customer support bot. The prompt works great with GPT-4 Turbo. 3 weeks later, the model gets a minor update. Nobody notices because nobody is testing. But the model now handles refund requests differently. It's more cautious, adds extra confirmation steps. Customer satisfaction drops. Support tickets spike. The team spends a week debugging their application code before someone realizes the model behavior changed. 3 weeks of silent failure because there were no evals. This is not hypothetical. A ZenML analysis of 1,200 production LLM deployments found that teams with systematic evaluation pipelines ship faster, not slower, faster, than teams without them. And Anthropic's research shows that teams with proper evals adopt new models in days, while teams without them spend weeks manually retesting everything. Here's the minimum viable eval setup. Take 20 to 50 real failures, bugs, user complaints, edge cases, and turn them into test cases. Split them into 2 groups. Capability evals, things the system doesn't handle well yet, where you're targeting improvement. Regression evals, things that already work, where you need to maintain close to 100% pass rate. Run these automatically every time you change a prompt, switch models, or update context. Use an LLM as judge with pairwise comparisons. Is output A better than output B for this input? That's more reliable than asking, rate this from 1 to 10. The teams that are actually getting value from LLMs treat prompts like code. Version controlled, tested, measured. Everyone else is just hoping it works. Not everything needs an LLM. This sounds obvious, but I see it constantly. Developers using language models for input validation, date formatting, basic math, data transformations, tasks where deterministic code is faster, cheaper, and 100% correct. Here's a real example that should make you uncomfortable. Imagine using an LLM to validate email addresses on a sign-up form. Most of the time, it works fine. But an LLM is probabilistic. Occasionally, it'll accept useri.com or reject a perfectly valid address with a plus sign. Now put that in a security-sensitive context, a password reset form, and you've just created a vulnerability that no unit test will catch, because the LLM's behavior is non-deterministic. A 5-line regex would have been bulletproof. Here's the context. LLMs are probabilistic. They get things right most of the time, but most of the time is not acceptable for validation logic or security checks. That compounding probability problem from my agent's video applies here too. 95% accuracy per step means only 60% success across 10 steps. The data backs this up. That Meteor study I mentioned? Experienced developers working in codebases they knew well saw no speed up from AI tools. In some cases, they were slower because they spent time reviewing and fixing AI-generated code that they could have written correctly in the first place. So where do LLMs actually help? Boilerplate generation, unit tests, documentation, code translation between languages, working in unfamiliar frameworks, small self-contained functions where you can verify the output quickly. That's the sweet spot. Adi Osmani from the Google Chrome team puts it well. He treats LLMs as powerful pair programmers that require clear direction. He writes a spec first, breaks work into small testable chunks, and reviews AI output like he's reviewing a junior developer's pull request. That mindset shift, from AI writes my code to AI drafts I review, is the difference. This is the dangerous one. A Stanford and NYU study found that developers using AI assistants produce significantly more security vulnerabilities than developers working without AI. And this is the part that should scare you. They were more likely to believe their insecure code was secure. The AI gives you confident, clean-looking code. It compiles, it passes basic tests, and your brain checks the done box. But that code might have SQL injection, improper input sanitization, or hard-coded secrets that you'd never write yourself. You trusted it because it looked professional. The GitClear data tells the same story from a different angle. That 39% increase in code churn means developers are writing code with AI. merging it, realizing it's wrong, and rewriting it. The AI isn't saving time, it's shifting where the time goes. Less time writing, more time fixing. And this is the real mindset shift. Your job is no longer writing code. It's managing context, pruning irrelevant information, adding useful material, writing detailed specs, and critically reviewing every line of output. Simon Willison talks about this a lot. The skill isn't prompting, it's knowing what the model needs to see and what it doesn't. If you skip that step, you're not using the LLM. The LLM is using you. Practical rules. Commit frequently as save points. Never trust AI output in security-sensitive contexts without manual review. For complex refactors, have the LLM write a plan first, iterate on the plan, then implement step by step. Last one, and it's a trap I see senior engineers fall into. They hit a quality problem and immediately think, we need to fine-tune a model. That's almost never the right first step. OpenAI's own documentation lays out the optimization ladder. Prompt engineering first, then RAG, then fine-tuning. These stack. You don't skip steps. I've seen this play out multiple times. A team spends 2 months collecting training data, cleaning it, running fine-tuning jobs, evaluating checkpoints. They get a model that performs maybe 10% better on their task. Then someone on the team rewrites the prompt, adds clear instructions, 5 solid examples, and structured output formatting, and matches the fine-tuned model's quality in 2 days. 2 months of work replaced by a better prompt. Fine-tuning is for stable behavior patterns, consistent output format, specific tone, lower per call cost at scale. It's not for adding knowledge. That's what RAG is for. And if your prompting isn't optimized first, fine-tuning just bakes in your bad prompts at a higher cost. Start with better prompts. Add retrieval if you need dynamic knowledge. Fine-tune only when behavior, not knowledge, is the bottleneck, and only after you've exhausted what prompting can do. Most developers never need to get past step 1. Those are the 6 mistakes. Vague prompts, over-provisioned models, no evals, using LLMs where code works better, blind trust, and premature fine-tuning. Fix even 2 or 3 of these and you'll get more out of LLMs than 90% of developers. The one-line version. Treat LLMs as a system engineering problem, not a magic box. Measure, structure, route, cache, review. That's it. Here's what I want you to do. Pick 1 mistake from this list, just 1, and fix it this week. If you've never structured a prompt, try it on Monday. If you've never run an eval, set up 10 test cases. If you're sending everything through the biggest model, route 1 task to something cheaper. 1 change. That's all it takes to start.